Okay, this is the beginning of 2.1.1's review and preview. 2-4, Jamila was moving to a new city. She has researched the rates charged by the local utility company for water. She found the listing of charges below. She expects that her family may use up to 1,000 cubic feet of water each month. So here's the first thing, three things you're seeing here are some things that are important to keep track of while you're looking at the graph. So we have a $12.70 monthly service fee, and that is here. That's just when it's zero, it's at $12.70. Okay. Then we have first 300 cubic feet of water used, it's $3.90. So 100 cubic feet or a fraction thereof. So as I go up to the first 100, I'm adding $3.90. Same thing here, $3.90, and then $3.90. Now, the one thing that's interesting about this, you can see this graph. I did this with Desmos, and you can't really tell. There's no solid circles or open circles on this, so you don't know which one is what you're collecting. So if I go through, and I'm going to say, well, at 100, it's $3.90 plus the $12.70, so it's going to be solid here and open here. That's how it keeps it on the path to being a function. Same thing here. This would be open, and this would be closed. Open, closed. Now, the thing is, when we get to 400, it starts going up by, and you can see this right here, it's 520, 520, and then 520. And it would go up to 520 if I put more points in as well. But the same thing. This is open, this is closed. This is called a step function, greatest integer function, floor function. There's a lot of different things this is called. You don't use this as much, but it's important to be able to understand what the graph is. So on here, it's asked me to sketch a graph and be sure to consider the cost of fractions. So if I decided I wanted to know how much it was going to cost me for 250, okay, that's going to cost me the 1270 plus 390 plus 390 plus 390, okay? Because this is saying that we round up. So we're rounding up to the top. Because once you go over the 200, then everything you use from 201 up to 300 is going to be adding that $3.90 on. Now, this is A, pointing to the graph. B, it's asking us, is this graph a function? Yes, and it is. And I've talked about this multiple times in other videos, but if I get a vertical line here, every X can only have one Y. And so I also do a thing called a vertical line test, and this is not very straight. I could make it straighter, but look how I'm going through these points and not very prettily. Prettily, is that even a word? I don't even know. Okay. Every single one of those points that's above each other, one is open and one is closed. So it is a function. If one of them was closed, then it wouldn't be a function. But this passes the vertical line test, so yes. And I can just clearly just say passes vertical line test. And every X has exactly one Y. Okay. Then the last thing it's asking. So what are the domain and range of this graph? Well, the domain is all real numbers. Well, actually, technically, it's not all real numbers. I would say that the domain is X is greater than or equal to 0, because you're not going to go into the negative. So that's your domain for this particular function. Now, the range is interesting. It is specific values. So it's going to be 1270. So if I write this in roster notation, 1270, then 1270 plus 390, and then 1270 plus 390, and you go on, so on and so forth, because it'll be 1270 plus 390, then 1270 plus 520, plus 520, and plus 520. So it doesn't have all of these values. Like there's no values in between here, none in here, or here. So it's seriously at each step is what's in the range. Okay, That ends 2-4. Okay, so for this particular problem, it wants us to look at parts A through D and find the input value that gives the smallest output value. In other words, find the x value of the lowest point on the graph, and then find the input value that gives the largest possible output, or the x value of the highest point on the graph. So it's kind of difficult because on A, B, and C, the minimum is pretty easy to find. The minimum x value is going to be whatever makes the parentheses 0 or whatever makes this is the point. So at the bottom of A, there's my minimum. So my x value there is going to have to be a 2. So the 2 is the lowest input to get the output there. Here, it's 0 that is the lowest x value to get the lowest input or output value for that particular parabola. And for C, it's -3. Now, all of those have minimums. And I'm just going to abbreviate here, a minimum and a minimum. It's because their parabolas are opening up. Now, it also says then find the input value that gives the largest possible output. Well, on A, B, and C, it's -infinity and positive infinity that will give you the highest y values. So because it goes from -infinity to positive infinity, and this is interval notation. So you're not going to be able to get to an x value that's actually producing the largest y value because you can't get to infinity, but it goes to -infinity and positive infinity. Now, D is different because D has a maximum. This is a maximum, okay? So I can put in 0, and so that's like a -0 squared, which we know can't happen, plus 5, and it's going to give me 5 as my maximum output, okay? And then also, when it asks for that minimum input, the x value, it's not going to happen. It's going to be -infinity to positive infinity again, okay? So where we have a maximum on this, we're not going to be able to find the lowest x value to produce the lowest y value because it goes to -infinity for both x and y. So hopefully that helps you understand, and I've answered all those questions that are a part of E because we have 3 minimums and we have a maximum on this page. And so hopefully that's helping review a little bit of the quadratic concepts. So thanks, I'm moving on. Okay, so 2-6 isn't going to take long to talk about. You see where we have the first graph is here. And then we have the -3x squared is the blue. And we have the -0.2x squared is the green. What you can tell here is when we have a positive coefficient on the x, our parabolas are going to open upwards, okay? But when we have a negative, which we have here, think about that. You're looking for that output value. If I have a negative slope, so to speak, a negative coefficient, and it multiplies by x squared, x, no matter what it's going to be, if it's squared, is going to be positive, but I'm going to be multiplying it by a negative, which then makes our parabola go downward, okay? So on a negative coefficient, always on a parabola produces a graph that points downward. That's also if I had an ax squared plus bx plus c. If there was a negative out here, that would make the parabola open up. Down, opens down. If it was positive, it would open up. So hopefully that explains a little bit more about what these graphs look like. All right, moving on. All right, for 2-7, this is going to help you apparently with lesson 2.1.2. And on this, it asks you to draw the graph of y equals the quantity of x minus 3 squared. If you are drawing the graph by hand, be sure to use the domain 0 is less than or equal to x is less than or equal to 6. So what I did is I just put it into Desmos, and I used the table that you see right here to graph this particular parabola. Okay, so that's now graphed. Now what I'm going to do is I'm going to go ahead and get the picture of it with both on the same graph. So hang on just a second. And like magic, it just shows up. Okay, So we have here, this is the y equals x squared. That is also called our parent function. And this is going to be something that you catch on as we talk about the translations of different graphs going left and right and up and down based on their equation. If you notice here in this equation, we have x minus 3. Well, if you also notice, that translated over 3 units. So we'll get into the form of those equations. But if you see an x minus 3 in parentheses, that means you're going the opposite direction of what you would think. If it was x minus 4, we'd be moving 4 in the positive direction. If it was x plus 3, we'd be moving to the negative 3. So those are things you're going to learn more about, but this gives you an idea of what these graphs should look like. Okay, moving on. Okay, this says consider the sequence with a first term, that should say term, oops, of 256, followed by 64 and then 16. What are the next 3 terms going to be? Well, to me, everything's been divided by 4 or multiplied by a 0.25. So 256 multiplied by a 0.25 or 25 equals 64. 64 divided by or multiplied by a 0.25 is 16. That means my next 3 terms are going to be 4, which multiplied by 0.25 would be 1, which multiplied by 0.25 would equal 1/4. Those are the next 3 terms. So my equation goes back before 256. That's going to be 4 times that 256. So we're going to go 1, 0, 2, 4. And that is times 1/4 to the x. Okay. So in this case, we have an exponential function because our variable x is actually in the exponent. And so I'm going to go ahead and show you a graph of that in just a moment. On part B, if I was to keep doing that, I would end up, what would happen to my terms? They would become larger fractions or larger denominators. So like 1/4 would become 1/16 times 4, 1/64, then 1 over 256. So you see what's happening. The numerator is staying the same, but the denominator is getting larger as you go exponentially. Sketch a graph of the sequence. What happens to the points as you go farther to the right? Let's take a look at that. Okay, I'll be moving this graph over a little bit in a minute so we can read all of part D, but take a look at what happens to the graph here as I go farther to the right. As my x values get farther to the right, if you take a look at what's happening here, oops, take a look what's happening here, my fractions are getting smaller and smaller and smaller, but they're never going to hit 0. So we have an asymptote here. Okay. And that's what's happening to the x values as you get farther and farther out, or the y values, I'd say, not the x values. Okay, what is the domain of the sequence? Well, let's move this over. The domain of the sequence is going to be all x values. Okay, we can use all x values in this. That's all real numbers. So domain is all real numbers. This might look like an asymptote, but it is not. If you go up, you will see it crosses the x-axis at 1,000, at 0, 1,024. But the range is y is greater than 0. It never hits 0. And that answers all the questions for 2-8. Okay, so in this particular problem, we have 4 graphs that we're being asked to look at. A, B, and C are pretty easy to do without any writing, and so we'll look at those in a moment on the video. But D, we need to do a little bit of work. Now, they've given us 2 points here, so we could calculate slope and figure all that out. But I'm just going to go ahead and use the point slope form, which is y minus y1 equals m times x minus x1, okay? Well, we can figure out the slope. So if I go over here, and I'll have to erase this in a minute, but if I go over here to D, we can figure out our slope. I'm up 2 over 3. So I know that my slope is 2/3. I also know that they've given me 4, 0 as a point. So that's the point we're going to use. I'm going to put x minus 4. Then on the other side, I'm going to put y minus 0. And that's just to show you what I'm up to. All right, so then it becomes y equals 2/3 x. And then you multiply the 2/3 times, and it should be, yes, it's a positive, good. So negative 4 times 2 is negative 8 over 3. So minus 8 over 3. And that is your slope. So that means my y-intercept is at negative 2 2/3, 0. Now, you will see that, and it will be checked on this video. So here we go. Okay, so this is 2-9, and I'm going to go ahead and use the homework tool, homework E tool. The only one that needs a little bit more work is 2-9D, and you just solve that in the graph on the slide. So we'll add that in at the end. The rest of them we're just going to do by looking at the graph. Okay, so it wants us to write the equation for each graph. And 2-9A is the orange line. Okay, so I'm just going to go look at my y-intercept. Okay, so I know there that I have y equals, and I'm going to put a negative 4 right now. But then I'm going to go in front of it because I got to figure out what my slope is. So let's see what my slope is. So if I go down 2 over 3, that's going to be, because of the direction of the line, a negative 2/3 x graph. And notice how it changed to green. That means I did it correctly. Okay. 2-9b, which already is in green, is just a horizontal line. And it's at the y-intercept of 0, 2. So that line is just y equals 2. And you'll see how it just changed to orange for us, okay? Type the equation below for the red line. Well, the red, you're lucky in a Texas Instrument calculator. I have not figured out how to do a vertical line. I'm sure there probably is a way, but I just haven't figured it out. But in this Desmos activity, you can type in just x equals 2. And that also is not a function, because obviously every x doesn't have just one y, okay? So then we have our last one. Now we just solved this on paper, so I'm just going to go ahead and type it in. So let's see if I'm correct. So it's y equals 2/3, x, I'm going to get out here, and minus 8 over 3. And if you notice, it changed to red, and that shows all of the graphs and the equations for that particular problem. All right, we are done with this little recording. So on this particular problem, we are going to be using the distance formula, which is right here, in case you forgot it or you don't know it. And we're going to calculate the slope, but we already know the slope is 5. But we're going to use the slope formula to find out what n is, because they want us to solve for n. So that should be y1 there. Then x2 minus x1. All right. So I'm just plugging in the values I know. So the value of the slope is 5. And then y2 is n minus our y1, which is a negative 1, over x2, which is 2, minus a negative 3, because our x1 is negative 3. I'm going to go one more step here, though, and convert some of these things that are negative to plus. So n plus 1 over 2 plus 3. So that's going to be 5 equals n plus 1 over 5. Now what we're going to do is multiply by 5, so we can get this 5 out of the denominator. So that means 25 equals n plus 1. We subtract 1, and n equals 24. So we now know that our point is B is 2-24. Okay, so what we do with this distance formula is we actually plug it in with the values that we have. So I'm going to go ahead and start by plugging in. We have x2, which is now 24. I'm sorry, 2, minus x1, which is negative 3, squared, plus our y2, which we now know is 24, minus our y1, which is negative 1, squared. So we're going to have 2 plus 3 squared plus 24 plus 1 squared. So that's 5 squared plus 25 squared Okay, and so that's 25 plus 625. So that is 650. So the square root of 650, which equals approximately 25.5 units, whatever that units is, okay? And that is your final problem for 2.1.1's review and preview. And we'll see you on the next video. Remember, subscribe if you like it. Leave us comments if you have questions about any of the math. And give us a thumbs up if you enjoyed it. All right, thank you so much, and see you on the next video.